Alright, so I've got a stem and leaf plot here, and this is just one I made up. I'm calling it temperatures in January in degrees Fahrenheit, and I've got 31 observations or data points there, pretending that are the average temperature for those 31 days, for each one of those 31 days. And I kind of actually I lived in Iceland for a while, and I was just kind of remembering back on the weather in Iceland in January, and sort of wrote down some data values that were fairly realistic for that time of year in Iceland, at least as far as I can remember. And so let's just talk about why would we use a stem and leaf plot? What's their usefulness? What's the point? Well, one reason would be you can write down a bunch of numbers in a compact way. Um, so the stems here are the first digit of the numbers, and then the leaves are the last digit. So um, all these numbers here have a first digit of 1, and then these are the last digits. So actually, uh, this means 11. Uh, this also means 11 degrees Fahrenheit. This means 12. This means 12. This means 12. This means 12. This means 13. This means 13. 14, 17, 19. So this would be 21, 22, 25, 29, etc. So it's a really compact way of writing a bunch of numbers. I've got 31 different values here, but expressed in you know a small amount of space. So that's one advantage. Uh, Two, I can see the order of the values, the smallest to the greatest values. So here I've got 5, 6, and 7 degrees. Those are the lower values. Here I've got 31, 32, 33, 33, or 31, 32, 32, 33, and 34 degrees. So uh, my highest observation was 34 degrees Fahrenheit. My lowest is 5 degrees Fahrenheit. So it's easy to see what's the lowest and highest value. So we can kind of see the range of the values. Um, Another major benefit is we can see the distribution of the data, which means how are the data distributed? What kinds of values are there most often? What kinds of values are there least often? So for example, I can see, well, the most of the or the temperature range with the highest number of observations, or the most days where it was within that range, is the tens. All right, I can just see visually these leaves stick out the farthest. There's the highest number of observations there. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. On 13 days, the temperature was in the tens degrees Fahrenheit. So, on this day, 11 degrees, that day, 13 degrees, 13, 13, 17, 19 degrees. And I can see in general, for the most part in January, the temperature was between 10 and somewhere in the 10s and 20s degrees Fahrenheit. So I can see, yeah, it's actually pretty mild. And that's true. Iceland it gets those warm ocean currents, so it brings the warm air and etc. Anyway, that's a tangent. So we see the distribution of day, and I see it really didn't get down below 10 very much at all in January, just on 3 different days. So yeah, that's what we call the distribution of the data, and that's really, I think that's the main advantage of the stem and leaf plot, is you can just eyeball it and immediately get a sense of what ranges of values have the most values. So yeah, so those are some of the advantages of the stem and leaf plot. They're good for medium-sized sets of data. You don't want to record 1,000 observations on the stem and leaf plot necessarily. That might not be that useful, um, but yeah, for something like this, 31 values, 100 values, something like that, it can really help you visualize the patterns in the data and help you pick out smallest value, highest value, etc.